Alright guys, we got part 2 coming up here shortly. It's going to dive a little deeper into the process of what actually physically happens into the installation of a rear gear.
3 a.m. in the morning, and I'm sitting all alone. Nighttime man makes me shiver, I can feel it in my bones.
Alright guys, now that you've kind of seen a basic video of why we want to regear our trucks or why we're considering regearing our trucks, we really kind of want to dive into some of the more technical side of things and really show you, how to set up gears and why it really is truly important to have a professional that has been doing this for years set your gears up.
So won't you come back, baby? Should've never walked away.
So this is going to be a 456 setup for the Fitchin 4Runner, which is this guy on our lift right here. So when we buy them from Nitro, it's going to come with basically a full kit. So front gears, rear gears, and all the bearings, crush sleeves, and necessary shims to get it set up. This is going to be a ring gear. This is going to be a pinion, right? And these 4 bearings are going to be carrier bearings, and these are going to be your pinion bearings. So this is a 456. So on the Fitchin 4Runners, it's actually going to be an 8.2 inch ring gear, and then the front is going to be an 8-inch ring gear. So this is going to be the front, this is going to be your rear. So basically we're replacing all of the bearings in the differential at the same time. They're going to all look, even compared to factory, they're going to be very similar looking. You will notice that you're going to have probably less teeth on your pinion, which is this guy. And that's going to be the biggest variance. And then you'll notice that on a lower ratio, you're going to get a much thicker gear on the ring gear side. Cool. So we're probably going to talk on this for a little while. This is going to be the rear third member on the Fitchin. Most Toyota truck applications are going to have a third member just like this. It's going to look very, very similar. The third member is really nice to work on because you can put it on the bench and gear it and fine tune it. Versus a Jeep, you're actually pulling it in and out of the vehicle as you're making adjustments. You're going to be very, very similar to pretty much any Toyota truck rear axle that's going to be out there. So, we're talking Tacomas, 4Runners, Tundras, dating way back. So this is basically the rear differential assembly. A real basic way of looking at this is your drive shaft's actually going to come in here. So your power from your engine's coming to here. As that power comes back through the pinion, it's going to be spinning your ring gear and then distributing the power to the tires. So axle shaft's out this way. This is an E-locked axle. So the actuator mounts out here on the outside, and it has a fork right here. That fork pushes inward to engage and lock the differential so that both the axle shafts spin at the same rate going out. When it's unlocked, this should actually just slide out like that. So that would be unlocked. Pretty cool, really. This process is just locking the rear diff. This is just going to be the E-locker. So not everybody has this. You have to be like an off-road or a pro. It just basically is going to be a rear locker. This has nothing to do with the actual four-wheel drive system. And basically, if you were to go on an obstacle or like say doing a burnout, if you didn't have an E-locker, you would only spin one tire, right? Well, if you have an E-locker and you engage it like that, bam, both tires are going to spin evenly. So perfect power distribution. Now, if your car was always locked, it would hop going around corners. So that's why you have basically an actuator that'll unlock it and lock it for you. Real pretty straightforward, really cool technology. Now kind of get back into some of our parts and what we're doing here in the regear. And this is the pinion. This is going to be your inner pinion bearing. From there, it'll have a crush sleeve, and it'll have an outer bearing like that. Now how crush sleeves work is basically we apply a certain amount of torque to the pinion nut, and this will actually expand. It's got a little bit of a bubble to it right here. And basically what that's going to do is it's going to create a preload on your inner and outer pinion bearings. Why that's important is This can't have any play in it, otherwise it'll be bouncing around and make noise. So that preload is crucial, and generally people that are trying to do something on their own or people that don't know what they're doing will get the incorrect preload, which will cause either the pinion to come loose or it'll cause premature wear on your pinion bearings. This is the most common failure of somebody that doesn't know what they're doing when setting up gears. So this is basically going to go in your third member, and I'll just kind of show you. Basically, it's going to end up sitting right in here. So that nut that I was saying that we actually set the preload on is actually on this front side. So when we're disassembling it, we'll take this nut off, the flange will come off, and then there's a seal back here, and then there's the bearing. We can run a pattern on this one right now. So this is the factory gear. But basically, you know, the pattern is crucial to a long-term and quiet differential. So we're gonna roll it back around, and you can actually see where it's shiny at is where it's making contact. So you'll notice it's kind of in the middle of the gear. If it was really far to the outside or really far to the inside, that would be an incorrect pattern. You can notice in the factory, it's got a really nice centered kind of almost square looking pattern. We're gonna shoot for a very similar pattern after our regear. And how we adjust for pattern is actually gonna be basically these side bearings. We can actually move the differential either way. And then we can also move the pinion up or down as well. Those are two ways to change the pattern, and they actually correlate together. So if let's say we make the pinion go up higher,
Yep.
we then have to shim or adjust this carrier out this way. Because if you hear this little bit of, that's called ring gear run out. And it's funny, like old school dudes will know by the sound how close their pattern is. So if you look over here, these are basically all of our setup bearings and shims, which are key for us setting up any type of axle. So like our regear specialist is kind of a mad scientist, right? So it takes a lot of years and a lot of practice to really get these down perfect. So it actually has shims on either side, right? And we can change the thicknesses of these shims, and that's how it's gonna actually move the differential.
Yep.
On this particular one, we actually remove these two bolts right here, and it actually has spanning bolts on the side, so you can actually turn these, and it doesn't use shims on this particular one. So these little guys are just cute little retainers. That'll give you a better idea too of what we were talking about with that pattern. Now the more that you run these patterns, the easier it'll be able to tell what the pattern looks like. We just did a real quick pattern, but you can see it's really centered in the middle of the gear, and then it's also centered on the back side as well. See it right in there. So now we're kind of getting down to that torn down part, where basically this is going to be your pinion. Pinion contact is actually extremely important as well. You'll notice it's really well centered, and you don't really see any paint, you know, real high up. You can see right where it's shiny is where it's making its main contact. So basically we're going to be replacing these bearings, which are going to be your carrier bearings on both sides, and the races. And then we're going to be replacing the pinion bearings as well in here. Let's maybe talk a little bit about the shimming process, which is really cool. I like it, it's easier. So basically, you know, these guys essentially are threaded so that we can move the carrier from side to side pretty easily. So they sit like that, and then you have to make sure that these are lined up correctly, but they will spin like that. And like, let's say, okay, I need to increase ring gear run out. We'd want to move the housing this way. So let's say you do a half turn this way, then you would reduce it by a half turn on this side. And like I was saying before, a lot of times these are actually shims, but on the 5th Gen 4Runner, they are a nice placement for a shim, which actually makes setup quite a bit easier on these. You know, you want these gears to match up, right? So that would be your space difference between the two. That noise that we were hearing, there has to be a little bit of play between the two. This is your pinion seal. The pinion seal is not reused. So we put a new pinion seal in there as well. So now we can see that we're basically back down to just our bare housing. All right, guys, as we're kind of diving into this rear diff and kind of showing you how we set diffs up, getting back to that crucial point where we're talking about pinion preload. This is a 5th-gen 4Runner rear diff, and Eric here is going to go ahead and work on getting this pinion preload set.
Working tool. So right here I got the handle on. This is a homemade piece that's got a bunch of holes in it that I bolted to the flange. This is just to hold it, otherwise this is going to drive it out of my hand if I don't. When I do it, you see how there's a lot of play in here. I'm going to try and get all that play out. So now I've got all the play out, but this is still too loose. I want to tighten it to where it's just about perfect. That's about where I want it. Now I'm going to take it off and verify my preload.
Nighttime and makes me shiver. I can feel it in my bones. So won't you come back, baby?
So yeah, if you had over crushed that, this actually physically squishes in the center right here. So if you had over crushed that, then you would always have perpetually too much preload on these, and this distance would be too small. So he's done it a couple of times. So
I got to calibrate the hand.
It's got a little stake that he's going to hammer in.
This is going to lock this nut down to make sure that it doesn't spin off. Now, these part, locker in there, erase, adjuster, I like this to be all the way out. This, another little finesse. When you go to install these have threads right here. And you got to mate up these threads. Very, very fine.
So you have a bearing here, a crush sleeve, and another bearing.
Yep.
And then obviously your new pinion, a new outer carrier bearings, and a new ring gear.
There it is. Once it goes nice. So right now we're going to adjust our backlash with our adjusters. Now, not every differential is as nice as this and gives you adjusters.
Oh, it sounded pretty good.
That sounds pretty close, but we want it perfect. So right now I've got about 15 thousandths of backlash, and I want 6 to 10 thousandths, between 6 and 10 thousandths of backlash. I'm just gonna back this one off a little bit, tighten up this one a little bit. Doesn't take much.
So he's effectively moving the ring gear this way.
And that gave me right at 8 thousandths. From there, we'll do one more pattern check. pattern. Now the clip goes like that. What's that?
So we go like that into the vehicle. So this would be the back of the vehicle. Pretty cool.
So won't you come back, baby? Should've never walked away. And I will keep on waiting for a better day.
There is a matter of getting the locker motor lined up properly with the locker cell. So you gotta, this piece comes off completely, and then there's the collar on the inside that this moves, this gear meshes in with it and moves the locker inside it, in and out. This is what they look like when they come apart, but this is the locker itself, and you see that this piece here meshes in with that, and that is attached to your spider gears, and that is one of your spider gears. And when the locker motor moves on a fork that this rides on, this will spin just like that, and when the locker engages, the motor will shift and then mesh those two together, and then this is all locked as one now. The transfer case is in neutral. It's a manual transfer case instead of your push button stuff, and you just kind of line up the holes. Another one goes in.
Alright guys, now that we've kind of got our rear differential fully completed on this 5th Gen 4Runner, we're going to go ahead and move on to the front differential. Front differential is quite a bit different, same overall concept as the rear, but we definitely have to have a matching gear set, front and rear. So we're going to go ahead and get cranking on pulling that out, and maybe we'll save that for another episode for you guys.
Alright guys, so that was part 2. It's a lot of information to take in, and even having edited the video myself, it's quite a bit of stuff. I hope y'all learned a lot. I certainly did, and that basically covers, you know, the installation of the back rear gear. We may do another video sometime in the future for the front rear gear, but we'll dive into that maybe somewhere down the road. But until then, peace out.